Instruction skill 20 is working with a scale drawing. And let's take a look first of all here at this box so that we understand what a scale drawing actually means. You are looking at a picture of an airplane, and the scale is 1 inch equals 13 feet 10 inches. So what this means, that airplane is very large. It looks like a 747, maybe a 737, but it's a big airplane. And there is no way that I could draw that plane in its actual size. I would need a piece of paper that is as long as the plane, as wide as the plane. That's just not practical. So I can use a scale drawing, and when something is done to scale, that means that it is proportionate. It is governed by the rules of proportions. So in this particular case, 1 inch on the drawing is equal to 13 feet 10 inches for the actual airplane. Now, that is not saying that this airplane is 13 feet long. That's saying that 1 inch in the drawing represents 13 feet 10 inches. So we're going to use the scale to represent the airplane in a way that we can easily draw it on paper. Scale drawings are very common with maps, in things like building plans, architecture, those kinds of things, engineering, just about any kind of engineering is going to use scale drawings. Okay, let's take a look at the test question. A scale drawing of an airplane is shown below. What is the length of the actual airplane? So someone has measured the distance from the nose of the plane to its tail, and on paper that's 3 inches long. And I know that every inch represents 13 feet 10 inches. So the answer would be 41 feet 6 inches. And that is about the size, I would estimate, of a 737. It's a big airplane. Scale drawings. A scale drawing and the object it pictures are similar figures. The drawing is the same shape, but not the same size as the object. Because they are similar figures, the dimensions of the scale drawing and the actual object are proportional. And this is a very interesting way to think about this. I've never thought about it this way. That drawing of the airplane is the baby, and the actual airplane that's sitting out at the airport is the mama figure. So you have that similar shape. Remember when we did this one where we had a mama and a baby in each of these? You have that same concept here. The drawing is the baby and the actual airplane is the mama. So to solve this, they say that measured on the drawing, the total length of the airplane is 3 inches. To find the actual length of the airplane, multiply 13 feet 10 inches by 3. And that gives you 39 feet 30 inches. But they had to simplify that by writing 30 inches as feet in inches. So they divided 30 by 12. And that comes up to be 41 feet 6 inches. Solving a scale drawing problem as a proportion, and this is what I would do. A scale drawing problem can also be solved as a proportion. In this problem, each ratio in the proportion is the actual size to drawing size. So actual is on top, drawing size is on the bottom. So we know that the mama plane, the actual plane, is 13 feet 10 inches for every 1 inch in the drawing. And L represents the plane's actual width. So you would draw the peanut around the 1310 times 3 and then divide by 1. So gist of this, we are still working with proportions. So let's try this out with a concept question. A scale map of Texas has the following scale. A half inch is equal to 15 miles. Which expression tells the actual distance d if the distance on the map is 5.25 inches? So I'm going to set this up as actual over drawing. You could use the word map. Whatever makes sense to you is fine. So the actual distance is 15 miles. So this is in miles. And that is represented by half an inch on the drawing. So this is in inches. And then we know that on the map, we're looking at 5.25 inches. And we want to know what that actual distance is. So I'm looking for something that puts 15 over 0.5 and d over 5.25. And remember, I may not see it here. We may have to rearrange some things. But let's see. I'm going to look for d over 525. That is going to be the easiest for me to follow. And the only ones that could possibly be it are right here. And neither of those are 525. So I'm going to go ahead and draw the peanut. I'm going to go ahead and put a peanut around those two. And then I'm going to look for a proportion that has that same relationship. And I see one. That's a possibility right here. We have the 15 and the 5.25. This one, we do not have the numbers that we want, so this is not it. 0.5 and 525, that is not what I'm looking for. 2.5 is not even in the problem, so I'm going to take that out. And then here I have 15 times 0.5. That is not what I'm looking for. So I'm going to go with number 1. The 15 and the 0.5 are together. They have chosen to do theirs this way. Here's how they set it up. And it's perfectly fine to do it this way. They did drawing to actual. So they said that 0.5 is really 15 miles. And then 5.25 is the distance that we're trying to find. And if you notice, the test is the peanut. If the peanut is multiplying the pieces, that's what you want to look for. Okay? So I like answer number 1 on this, but I hate concept questions. Concept questions are setup questions, and they have always given me fits. Procedure, I like better than concept, especially when I can use a calculator. On a blueprint for a house, the scale reads 1 inch equals 24 inches. So that means 1 inch on the print is 24 inches on the actual house. So the blueprint is the baby, the actual house is the mama figure. What is the actual length of a window that measures 1 3/4 inches on a blueprint? Well, the first thing that jumps out to me and that I really like to see is that we're dealing with similar inches. Okay, so we can't necessarily rely on that. We're going to have to look for something a little more than inches. So here we have actual That's one of our dimensions. And let's use blueprint as our other one. You could call it drawing. You can call it whatever. You don't even have to call it blueprint. You could just put whatever makes sense to you. But I would encourage you to put something, because if you don't, you are apt to get these things in the wrong place. So I'm going to say print to actual. And I know that 1 inch on the print represents 24 inches, or 2 feet on the actual. And then we're dealing with 1 3/4 inches on the blueprint. Now I can use the calculator, so you can definitely do a fraction. I'm just going to put 1.75 because I don't really like fractions if I don't have to do it. So here comes the peanut. And remember, you can use the calculator. You always multiply a peanut. So I'm going to say 24 times 1.75 equals, that's 42. I'm having pen problems tonight. 42 divided by 1 is still 42. And that's 42 inches. Okay. Then I'm going to divide 42 by 12. And that's 3.5 feet. And remember, a half a foot is 6 inches. So I'm going to go with option 4. So you have to know how many inches are in a foot and be able to work with that pretty easily to be able to do this one. That's a good problem though. It's an actual real life problem. Probably not something I'm going to do because I don't build houses, but it definitely is practical. Number 3 is something I have done many times before the days of GPS. To find the distance between 2 nearby cities, Sean looks at a state map. He measures the map distance between the cities to be almost exactly 2.5 inches. If the map scale reads 1 inch equals 15 miles, what is the distance between the cities? So I'm going to set up the map distance to the actual or real distance, whatever makes sense to you. And the scale is 1 inch to 15 actual miles. And then the other number in the equation is 2.5 inches. So I'm going to convert that to 2.5. And then I'm going to multiply the peanut. And I cannot use a calculator on this one. So let me show you something. On this one, I would actually use a fraction, because I can do this in my head better than I can do decimals. But we have to make this mixed number mad. So I would say 2 times 2 is 4, plus 1 is 5/2. And that's what I would put in the peanut. So I have 15 times 5/2. You can put a 1 on that 15. And that's going to give me 75/2. And we have to keep going. So 75 divided by 2. If only I had a calculator, I wouldn't have to do this. 7 times 2 is 14 with 1 left. So 37.5 miles. I like answer number 3. And you really need to do those computation pages to know how to do that without a calculator. All right, number 4. These are my favorite. These are applications where I actually apply the concepts and the procedures to a real life story. Jose made a scale drawing of a sailboat. The length of the sailboat in Jose's drawing is 8 inches. The actual length of the sailboat is 40 feet. Which of the following scales should Jose write below his drawing? So again, we are comparing a drawing to an actual. And don't let this one rattle you. It's a little bit different, but you know what you're doing. The length of the sailboat in the drawing is 8 inches. The actual sailboat is 40 feet. So start with that part. And then look at your answer choices. What do all of them have in common? They want to know the unit rate. They want to know what 1 inch would equal. So I'm going to put a 1 in this column, in this row, and then I'm going to work my magic. 40 times 1 is 40, and 40 divided by 8 is 5. So 1 inch is equal to 5 feet, and this is your answer. I actually like that. I don't think I've ever seen one work that way. Usually they give me the scale, the 1 inch part, and ask me to find the bigger numbers. But in this one, they went the other way. Good thing is that proportion will work every time. Problems 5 and 6 refer to the drawing below. I did something like this just about a month ago. I'm renovating my house and this came up. Corner deck plans. My deck is not exactly a triangle, but it's very close. 1 inch is equal to 8 feet. And let's make sure we understand some vocabulary here. This is the length. This is the width. And this is the diagonal. The proper name for diagonal is hypotenuse. So they could very easily use the word hypotenuse. And then my scale is right here. 1 inch on the drawing represents 8 feet in reality. If the width of the scale drawing is 2.25 inches, so that's that red line that I drew, what is the actual width of the deck? So we are comparing the drawing to the width. So the drawing 1 inch represents 8 feet, regardless of where it sits on the drawing. And our scale is 2.25 for the width. So I will be multiplying that by 8. And I do not have a calculator, but this time I will do it with a decimal. You can do it with a fraction. I would probably do it with a fraction, but you can choose what you like. Then 18 divided by 1 is 18. And that would be number 3. So the width up here we have found to be 18 feet if you're using 2.25 as the actual width on the drawing. Okay, if the width of the scale drawing is 2.25 inches and the length of the drawing is 4 inches, what is the actual length of the deck's diagonal? Oh boy, let me think about this one, because we have not covered Pythagorean theorem yet. I'm going to come down here and duplicate that picture, just because I don't want to keep flipping up and down there. So we have a right triangle, and this tells us that the width on the drawing is 2.25 inches. And the length on the drawing is 4 inches. I don't really know another way to do this except Pythagorean theorem. I tell you what, I'm going to look at the answer key and see what they want me to do here. I would do it with Pythagorean theorem, but we've not covered that yet. In fact, I'm sure this book covers it. What, I already forgot. Skill number 20. Bear with me a second. I'm looking at pages and not skills. And there may be something that I'm missing, although they let me use a calculator. Nope, they're doing Pythagorean theorem. Okay. Do I want to do it first? I think I'm going to do it this way. All right, you have not seen this yet with me, but there is a formula that works for right triangles, and it is this. A squared plus B squared equals C squared. And C squared is always, C is always the diagonal. Okay, so we know that C is reserved for the diagonal. A and B, you can switch around. Those are the legs of the triangle. And they're actually connected to the right angle. So those are interchangeable. I tend to think of the 4 there as the base, but you can absolutely do it however you want to do it. But we need to square or raise to the second power both of those dimensions, and they have given me a calculator. So 2.25 to the second power, it's ugly, is 5.0625, and 4 times 4 is 16. I can do that in my head, and then I need to add those two together. That's going to be 21.0625. That is C squared. And then let's take the square root of both sides, use the calculator. So it is about plus or minus, I'm going to say 4.6. And that's inches. That is the length on the drawing. And then I'm going to have to turn that into actual feet. And this is where I have to do my proportion. This is a good question. Drawing to actual. We know that the scale drawing is, what was the scale? 1 inch is 8 feet. 1 inch is 8 feet. And we're going to use that approximately 4.6. So I will multiply using my calculator. That's 36.8. And I will divide by 1. So in reality, we're looking at about 37 feet. So I'm going to go with answer number 4, and I am going to check that just to be sure. Yes, that is correct. They actually, in the answer key, went ahead and calculated the actual feet. We already knew that this one was 18 feet from the problem above, and they did it that way. They did the feet and then the Pythagorean theorem, and that's fine. I just would prefer to work with those smaller numbers on Pythagorean, but I had a calculator, so it really would not have mattered. That's a good question, but it's not an easy one. Again, if you haven't looked at the computation for this page, I definitely would look at those pages at the bottom because you need those math skills to be able to do this math. You really need to be able to compute before you even try the theory because it's a lot easier that way.